In this video, I'll cover the most known collections for Java developers and break down their pros and cons. Let's dive in. One of the most common Java collections that we are going to see on any project is ArrayList. And one of the reasons is that when we are using array, we have to specify the size of an array. However, with ArrayList, we don't have to specify that. Another very good benefits that not many Java developers know is that ArrayLists are CPU cache friendly. And the reason is that ArrayList stores all its elements in a contiguous block of memory, allowing the CPU to load multiple elements at once into its cache lines. So if we need to loop over the next element, the CPU will need to access the RAM because they will be already in the cache. About the operations that we can do on ArrayList, we can add elements using the add method that receives the object that we want to add. We can access any element of that array using its index by using the method get. Also, we can use the method contains to verify if an object exists on the array. And also we can use the method remove to remove an object on the array either by specifying an object or specifying the index. About the time complexity of ArrayList, accessing any element by its index as a constant time. Searching an element in the list is O of n. Adding an element is constant. However, if the array needs to be resizing, it would cause O of n. Inserting an element and removing an element, it will cause O of n. One of the issues with ArrayList is that if the list grows beyond its initial capacity, then it has to create an array with a greater space past the elements on the old array to the new one, and it has a time complexity of n when inserting an element when that happens. So what LinkedList solves is that instead of saving all the elements in a contiguous block of memory, it saves the elements on different parts of the memory, so it doesn't have to resize or anything like that. Regarding the operations that we can do with linked list, we can do add to add a new element into the list. We can use get to get an element based on its index. We can use constraints to verify if a specific object is in the list, and also we can remove an element by passing its object. About the time complexity of linked list, accessing any element by its index, it calls O of n. Searching element, like when you want to verify if a specific element is in the list, it calls O of n. Inserting an element either in the beginning or at the end, it has a constant time. Deleting an object in the list by index or by object, it has a time complexity of n because it has to go through every object until it found that object from the beginning. HashSet is another very common collection, and usually we use that whenever we want to guarantee that the list has unique elements. About the operations that we can do over there, we can add an element using the add method. We can check if a specific element or object is in their method. However, we cannot access an element using the index of that object. About time complexity, we have a constant time when accessing an element, also when removing an element, and when adding an element as well. Whenever we need a key value structure, we can use HashMap. And the thing with HashMap is that we have to make sure that we override properly the equals, and to add a new entry into the HashMap, we can use the method put, where the first parameter will be the key and the second one will be the value. To verify if a specific key exists on the hash map, we can use the method contains key, which receives the object that represents the key. To remove an entry from the array, we can use the remove method, which receives the key object. So if that key exists on the hash map, it removes that entry. In case we need to go through every element on the array, we can use the for each method, and over there you have to specify a lambda expression where you are going to receive the key as first parameter and value as second parameter. Also, there are other ways to loop over the entries of a hash map. Regarding time complexity, it has a constant time complexity when we are adding elements, as long as the hash code is properly distributed. Also, the constraints key method has a constant time, and remove method has a constant time, as long as the hash code is well implemented. ArrayDeque is a class that implements the queue interface, and ArrayDeque guarantees that the first element that you insert in the queue will be the first element that you will get from that. So the elements will be in order of insertion. To add an element into the queue, you can use the add method that is part of the queue interface. At first, to add an element at the beginning of the queue, and at last to add an element to the end of the queue. Pick retrieve the current element at the head of the queue, but it doesn't remove it. If you want to retrieve the current element at the head, and also at the same time you want to remove that from the queue, you can use the method poll. You want to use a queue, but you want to have a specific order of the elements that you have on the queue, then you can use a priority queue. To add a new element into the queue, you can use the add method. To retrieve the current element at the head of the queue, you can use the method pick, and to retrieve and remove the current element at the head of the queue, you can use the method poll. Regarding time complexity, adding a new object into the queue has a cost of log n. Using the method pick has a cost of 1. Pulling an element from the queue has a cost of log n. If you have any questions, don't hesitate to make any comment. Also, if you really like this video, probably you will like this other video about a roadmap for Java that actually works. Also, this other video about 6 very common Java mistakes that Java developers often make.